Imagine a single gallon of liquid worth $39 million. Scorpion venom, more valuable than gold. Extracted drop by drop from ancient arachnids, this venom is now at the center of a high-tech, billion-dollar industry. Across the globe, specialized farms breed and milk scorpions, harvesting their toxins for life-saving medicines. Today on AgriCraft, we reveal the secretive world of scorpion farming and the science behind the world's most expensive liquid. Discover how this venom is transforming medicine, from cancer treatments to next-generation antibiotics. Join us as we explore the synergy of nature and technology in one of agriculture's most astonishing frontiers. Scorpion farming is one of agriculture's most lucrative and specialized sectors, generating millions from tiny footprints. In Turkey, China, and beyond, high-tech facilities breed thousands of scorpions, producing venom for the pharmaceutical industry. Only about 30 species have the potent venom needed for medicine, making them the focus of this global network. Their toxins are used to target cancer, treat neurological disorders, and fight drug-resistant bacteria. With venom fetching up to $115,000 per gram, scorpion farming is reshaping rural economies and the future of medicine. This is the new gold rush, driven by science, not metal. Once feared, scorpions are now at the heart of a biotech revolution. Scientific breakthroughs revealed their venom as a treasure trove of proteins and peptides, sparking the rise of scorpion farming. Entrepreneurs in Iran and Turkey transformed arid lands into high-tech farms, exporting venom to pharmaceutical giants. Facilities like Sanliurfa in Turkey breed thousands of Androctonus turkiensis, turning barren landscapes into innovation hubs. These aren't just farms, they're biotech centers exporting hope in the form of frozen venom powder. Scorpion farming proves that with innovation, even the harshest environments can yield immense value. Ancient fears have become modern fortunes. The scorpion venom industry is a global gold rush for molecules, not metals. Farms in China, Turkey, and Egypt focus on local species, each with unique venom for specific medical uses. A single gram of venom can be worth more than an entire herd of livestock, transforming rural economies. Controlled breeding reduces wild capture, protecting natural populations and supporting sustainability. These farms are now centers of scientific excellence, advancing medicine and conservation. Scorpion farming is redefining agriculture as a force for economic growth, science, and environmental stewardship. Scorpion venom is a complex cocktail of proteins and peptides, refined by millions of years of evolution. Compounds like chlorotoxin can target cancer cells, helping surgeons remove tumors with precision. Other toxins are being developed to treat autoimmune diseases and chronic pain. Only about 30 scorpion species produce medically valuable venom, making selection critical. Researchers isolate, synthesize, and modify these compounds, turning deadly toxins into life-saving drugs. The journey from venom to medicine is challenging, but the rewards are immense. This is how fear becomes hope in the hands of science. The potency of scorpion venom is no accident, it's the result of careful genetic selection and breeding. Farms use genetic testing to select scorpions with the most valuable venom profiles, ensuring consistency and quality. Environmental controls accelerate breeding and optimize venom production. Female scorpions, often larger and more productive, are preferred for breeding. These closed-loop systems protect wild populations and give farmers full control over production. Every step, from genetic selection to environmental management, is guided by science. The result, a sustainable, high-grade resource powering the future of medicine. Successful scorpion farming is a delicate dance between replicating nature and enhancing it with technology. The environmental requirements are designed to mirror their natural desert habitats, but with precise, technological control that wild ecosystems could never provide. Within modern processing plants, every aspect of the scorpion's world is meticulously managed. Temperature is one of the most critical variables, with facilities maintaining ranges between 15 and 40 degrees Celsius, depending on carefully planned seasonal breeding cycles. This environmental manipulation is a strategic tool used to guide scorpions through their life stages and maximize their biological output. This control extends to mimicking changing seasons to stimulate natural behaviors. During cooler winter months, facilities lower ambient temperature to around 20 degrees Celsius, inducing reduced activity similar to brumation. As simulated summer approaches, temperatures are gradually raised, sometimes reaching as high as 40 degrees. This heat signals scorpions to increase their metabolic rate and stimulates the glands responsible for venom production, ensuring the highest possible yield during harvesting. Humidity levels are just as crucial, kept stable between 50 and 60%, while automated systems maintain strict 12-hour light and dark cycles, completing the illusion of a perfect, predictable desert day, every day. The housing systems themselves are a marvel of agricultural engineering, designed for efficiency, monitoring, and well-being of each individual specimen. Scorpions are housed in individual transparent plastic containers, which allows technicians to monitor their health and behavior without causing stress from handling. These containers feature specialized ventilation systems and are arranged on vast industrial shelving units that maximize vertical space. This design allows a single facility to house tens of thousands of scorpions in a relatively small footprint. To complete the microhabitat, substrate at the bottom is seasonally managed. During warmer summer months, fine sand covers the container bases, mimicking the natural desert floor. When simulated winter arrives, sand is replaced with wheat bran, offering better insulation and bedding conditions. This controlled, clean, and optimized environment is fundamental to the entire operation. It ensures consistent production of high-quality venom by preventing disease, reducing stress, and eliminating contaminants that could compromise the pharmaceutical-grade product. In the world of high-stakes scorpion farming, the old adage "you are what you eat" holds profound truth. The diet provided to the scorpions has a direct and measurable impact on both the quantity and the quality of the venom they produce. It's not enough to simply keep the scorpions alive, they must be nourished with a specific diet that's optimized for toxin synthesis. Extensive scientific research has been conducted to determine the perfect menu. Studies performed on key species like Androctonus phenitimus and Hottentota tamulus revealed that a diet consisting of grasshopper nymphs and adults resulted in maximum venom yields, outperforming other common food sources like house crickets, houseflies, and moths. This crucial insight has led many large-scale processing facilities to establish their own dedicated insect breeding operations. These ancillary farms run in parallel to the main scorpion rearing enterprise, ensuring a constant, reliable, and high-quality supply of optimal nutrition. By breeding their own grasshoppers, the facilities can control every aspect of the food source, from its own diet to its health, making sure that no pesticides or contaminants are passed on to the valuable scorpions. This vertically integrated approach guarantees that the scorpion populations receive the precise nutritional building blocks required to synthesize the complex proteins and peptides that make their venom so incredibly valuable to the pharmaceutical industry. The delivery of this specialized diet is managed with the same technological precision as the rest of the environment. Overfeeding can be just as detrimental as underfeeding, leading to health problems and potentially reducing venom potency. To avoid this, many facilities employ automated feeding systems. These systems are programmed to distribute precisely measured portions of food to each scorpion at scheduled intervals. This meticulous approach to nutrition ensures that every single animal receives the adequate sustenance needed for consistent venom production without the waste or health risks associated with excess food. It's another example of how technology is used to standardize and optimize every facet of the farming process. Ultimately, this scientifically formulated diet is a critical investment in the final product. Just as a master vintner knows the quality of the grapes determines the quality of the wine, a scorpion farmer knows the diet determines the potency of the venom. By providing a consistent and optimized food source, farmers can ensure that the venom harvested is not only plentiful but also has the consistent chemical composition required by medical researchers. This focus on diet management is a fundamental pillar of the entire operation, directly influencing the farm's profitability and its reputation as a reliable supplier of one of the most precious substances on Earth. The harvesting stage represents the most critical and high-stakes phase of the entire scorpion farming operation. This is the moment where months of careful breeding, environmental control, and specialized feeding culminate in the collection of the precious venom. Historically, extraction was a manual and often traumatic process for the scorpions. Technicians would physically squeeze the venom gland, a method that not only caused significant stress but also frequently resulted in contamination. The pressure could rupture internal tissues, causing hemolymph, the scorpion equivalent of blood, to mix with the venom, drastically reducing its purity and quality for medical use. To overcome these challenges, modern processing plants have adopted a far more sophisticated and humane technique, electrical stimulation. This method yields higher quantities of pure, uncontaminated venom without causing lasting harm to the specimens. The process is precise and carefully controlled. Workers use specialized forceps to gently hold the scorpion while an electrical stimulator delivers a very low voltage charge applied near the venom gland. This mild electrical pulse causes the muscles to contract, stimulating the release of venom droplets in a controlled manner, mimicking the natural stinging process. This advanced, non-lethal method is a game changer for the industry's sustainability and efficiency. It allows facilities to milk the same scorpions repeatedly, typically on a cycle of every few weeks over a 6-month period. After this time, the scorpions become weakened and are retired from the production line. A single scorpion produces around 2 milligrams of venom per session. Therefore, to achieve commercial production volumes, facilities must process thousands of specimens every day. The Şanlıurfa facility in Turkey processes its entire population of 20,000 scorpions to extract about 2 grams of pure venom daily. The efficiency of this delicate art has been revolutionized through robotic automation. Moroccan researchers developed the groundbreaking VS4 robot system. This machine can process up to 35 scorpions simultaneously, moving them along a conveyor and applying programmed electrical stimulation with perfect consistency. The system's LED display shows species identification and automatically adjusts electrical parameters accordingly. This level of automation represents a major leap forward, ensuring maximum yield and purity, while making the process safer and more standardized than ever before. Once the venom is successfully harvested, the clock starts ticking. The raw liquid venom is a fragile biological substance, and its complex proteins can begin to degrade quickly if not handled properly. The journey from a liquid droplet to a stable transportable product begins with immediate freezing at ultra-low temperatures. This rapid freezing process is essential to preserve the intricate bioactive compounds and halt any enzymatic activity that could compromise the venom's integrity. Processing plants use specialized cryogenic equipment to flash freeze the venom, locking its valuable molecules in a suspended state and preparing it for the next critical step in its transformation. This next step is a process known as lyophilization or freeze-drying. The frozen venom is placed into a freeze-drying machine which creates a vacuum and slowly raises the temperature. This causes the frozen water content within the venom to sublimate, turning directly from a solid ice into a gas, water vapor without passing through a liquid phase. The result is a fine, stable powder, a highly concentrated form of the venom with all its potent toxins perfectly preserved. This dry freezing process is the gold standard in the pharmaceutical industry because it maintains the venom's chemical structure and biological activity, while creating a product with an extended shelf life. Before it is packaged, the processed venom powder undergoes rigorous quality control. Modern facilities employ advanced analytical techniques like mass spectrometry to verify the venom's composition and purity. This technology allows scientists to map out the distinct protein peaks within a sample. Venom extracted via electrical stimulation consistently produces around 12 distinct protein peaks, a clear indicator of its high quality. In contrast, samples from older, manual extraction methods often show only 5 peaks, along with signs of contamination. This stringent quality inspection process ensures that every batch meets the exacting pharmaceutical-grade standards required by global medical markets. Finally, the purified venom powder is ready for packaging. This is not done by hand but by automated systems designed for handling high-value, sensitive pharmaceutical materials in a sterile environment. The powder is precisely weighed and sealed in specialized airtight vials that prevent any contamination or moisture exposure. Each vial receives a detailed label with critical information, including the scorpion species, the extraction date, batch number, and quality certifications. These meticulously packaged vials are then moved to cold storage facilities, ready for their journey across the globe, connecting remote scorpion farms to the forefront of medical innovation. Once the venom has been transformed into a stable, purified powder, the final phase of its journey begins: packaging and distribution. This critical stage is handled with the same level of precision and technological sophistication as the rest of the production process. Packaging operations utilize fully automated systems designed specifically for handling high-value pharmaceutical materials. Inside a sterile clean room environment, robotic arms measure and dispense the venom powder into small specialized glass vials. These containers are immediately sealed with airtight stoppers to prevent contamination or exposure to moisture, which could degrade the delicate proteins within the product. This ensures the venom's potency remains intact. Each package is then meticulously labeled with information essential for the global pharmaceutical trade. The labels include the scientific name of the scorpion species, the specific batch number, the exact date of extraction, and detailed quality certification data. This comprehensive tracking system is vital for traceability and compliance with international regulations. After labeling, the vials are carefully placed into temperature-controlled shipping containers. These specialized cold storage facilities maintain the processed venom at precise, ultra-low temperatures throughout the entire distribution chain, safeguarding the product's stability from farm to laboratory, no matter where in the world that may be. With the product secure, A complex logistics network springs into action, coordinating the international distribution of this priceless cargo. These global distribution networks connect scorpion farming operations in countries like Turkey and China with the world's leading pharmaceutical markets across Europe, North America, and Asia. Turkey has established itself as a key exporter to nations at the forefront of medical research, including France, the United Kingdom, Germany, and Switzerland. Meanwhile, Chinese operations cater to a dual market, supplying both domestic traditional medicine and international research facilities, showcasing the global reach of this specialized sector. This international trade is more than just business, it is a vital supply chain that fuels medical innovation. The success of this global network demonstrates how specialized agriculture can create valuable export industries, even in developing regions. Strict chain of custody protocols are maintained at every step of the journey, ensuring the security and integrity of the shipment. From the desert farms to state-of-the-art laboratories, the global venom supply chain is a testament to modern logistics, connecting the ancient world of scorpion biology with the future of human health. The incredible value of scorpion farming does not end with the extraction of venom for pharmaceutical use. Savvy operators have realized that the entire operation can be a source of revenue, leading to the development of a market for valuable byproducts. Scorpion species that are common but unsuitable for high-potency venom extraction are not discarded. Instead, they are processed to create other valuable materials. The bodies of these scorpions are dried and ground into a fine protein-rich powder. This powder is highly sought after by the cosmetics industry for use in specialty creams and serums, and it is also a key ingredient in many traditional medicine applications, particularly in Asia. This integrated approach of maximizing resource utilization creates multiple diversified revenue streams from a single farming operation, enhancing overall farm profitability and sustainability. But the innovation doesn't stop there. Researchers have discovered that scorpion venom compounds have incredible potential for specialized agricultural uses. Studies have shown that certain peptides within the venom can be developed into a new class of environmentally friendly biopesticides. These novel crop protection products are highly targeted, affecting specific insect pests while remaining harmless to beneficial insects like bees and pollinators. They also decompose naturally, leaving no harmful residue in the soil or water, a major advantage over conventional chemical pesticides. The potential of this green technology has not gone unnoticed by major agricultural biotechnology companies. Industry giants like Monsanto have already filed patents for scorpion venom-based crop protection products, signaling a future where the scorpion's sting could help secure the world's food supply. Beyond medicine and agriculture, an emerging market segment is also developing for the nutritional applications of scorpions. With a high protein content and very low fat levels, scorpions are considered a healthy and sustainable food source in many parts of the world. Processing facilities in China, Bangladesh, and Vietnam are now supplying scorpions to bustling food markets. There, they are prepared as popular street food snacks, deep fried on sticks, or featured as exotic ingredients in gourmet dishes. These diverse culinary applications create an additional layer of demand for farming operations, further diversifying their market opportunities and strengthening their economic foundation. From life-saving cancer treatments and next-generation pesticides to high-end cosmetics and nutritious food, the humble scorpion is proving to be one of the most versatile and valuable creatures in modern agriculture. This market expansion ensures that every part of the operation contributes to a profitable and innovative enterprise, pushing the boundaries of what a farm can produce. From the initial, careful selection of breeding stock through to the final, global distribution of a life-saving pharmaceutical product, the journey of scorpion farming represents a remarkable transformation of traditional agriculture. This industry is a showcase of human ingenuity, demonstrating how we can take a creature once universally feared for its deadly sting, and, through science and technology, turn it into a source of hope and healing. These advanced processing plants, operating with the precision of a Swiss watch, convert desert predators into the raw materials for cutting-edge medical compounds. It is an industry built upon sophisticated industrial systems, where automated conveyor belts, robotic milking arms, and stringent quality control procedures ensure the consistent production of a substance worth millions of dollars per gallon. The seamless integration of cutting-edge technology with ancient biology stands as a powerful testament to how innovation can forge entirely new agricultural sectors. The scorpion farmers of today are not just tenders of unusual livestock, they are pioneers operating at the intersection of ecology, genetics, and pharmacology. Their processing facilities rival the sterile environments of traditional pharmaceutical manufacturing plants, all while maintaining sustainable production practices that help protect wild scorpion populations from over-harvesting. The use of advanced monitoring tools, automated feeding systems, and robotic extraction equipment ensures that optimal conditions are maintained throughout every stage of the production cycle. This is the new face of farming in the 21st century. As the global demand for specialized medical compounds continues to grow, scorpion farming operations are poised for significant expansion across suitable arid regions worldwide. These farms are already becoming vital economic engines, providing skilled employment opportunities in rural areas and generating valuable export revenues that bolster the economies of developing nations. The proven success of facilities from the deserts of the Middle East to the plains of China provides a powerful blueprint for the future. It proves that specialized agriculture, when paired with technological innovation, can transform even the most challenging environments into profitable production centers that serve the critical needs of global pharmaceutical markets. Thank you for joining us on this fascinating journey through the intricate world of high-value scorpion farming. The transformation of these dangerous desert predators into the source of life-saving medical compounds showcases the almost limitless potential of modern agriculture technology. From automated milking robots that gently harvest venom to pharmaceutical-grade processing plants that ship their products worldwide, this industry is a brilliant example of how innovation continues to revolutionize farming practices across the globe. This is not just about a single expensive liquid, it is about a new way of thinking, where the solutions to our greatest challenges might be found in the most unexpected of places, patiently waiting for us to discover them.